Hello AI and ML communities. Today I'm going to show you a simple math prediction on neural network. We will run the project on Google Colab and we will see how it works. Google Colab is an open source Python environment. It's actually very interactive. You can access 24/7 through a browser. You don't need to install any hardware. Google Colab comes with a graphics processing unit and tensor processing unit, TPU and GPU, so we don't need to install anything on our local machine. So let's start our code on the Google Colab, and then I'll walk through each and every step, and then I'll give you the demo. Go to colab.research.google.com, and then it will open up this page, and then you will get all the recent projects you worked, and then click the new notebook. When you click the new notebook, you will get a new page, and then we'll rename this file to simple math prediction. Okay, before we start the project, so what we need to do, we need to first check all the libraries and everything is installed. We are going to use a TensorFlow Keras, and then we are going to use a NumPy. So I want to ensure that before running any code, I want to check that those TensorFlow is having the latest version, and then NumPy is installed. So let's install so let's run it. So this is always install the latest software, because now you can see the 2.7.0. You don't need to mention any version on this. You just type it at TensorFlow, it will install always the latest version. And then we go to the next one is we will install pip install NumPy. So already I installed in this computer. That's what it says. I recommend already satisfied. This is also installed the latest one, so we don't have to worry about anything on that. Let's add a new one from TensorFlow .keras import sequential. Sequential is a plain stack of layers with one input tensor and one output tensor. I will explain detail in the later. And then I'm going to another one, TensorFlow .keras, and then we need a layer from import dense. So let me run and see, is there any error? No error. Dense is a densely connected neural network layer. It is a simple network layer, and it is a part of core layer on the Keras side. Before I introduce anything, I'm going to give you a neural network, how it works, how it looks, and everything. This is a simple neural network diagram. You can see the layer 1, which has 5 circles. Each circle is a 1 neuron, and the layer 2 has 3 circles and 3 neurons, and then the layer 3 has a 1 neuron. The first one is an input layer, and the second one, layer 2, is actually the hidden layer, and the layer 3 is the output layer. You can see that the one single neuron is, the line is connected to all the subsequent neurons. You can see that this neuron is connected to this neuron, and this connected to this neuron, and also it's connected to this neuron. And same thing, it goes to this, it goes to this, it goes to this. And also you can see the third one also connected to all the rest, because it's a closely connected neural network. That's what we call it as a dense layers. So we already saw that what is a neuron and how it looks. Let's go back to our code and write the code there. I need to import NumPy as NP. So that's a one thing I missed it. So let me import that. And then what I'm going to do next is I'm going to do the give the inputs. X is equal to np dot array. I will say, and then I'm going to give y value So what we are doing here is I given a list of X input value, and then I given output as a Y, because there is a relationship between the X and Y. In this case, there is a mathematical formula behind it. When I give a X, and then it will produce Y, the value. So I'll pause it for a few seconds. Probably you can find it, what is the formula behind this. Yeah, so that is nothing but it's actually the formula is y equal to 3x plus 1. So when you say y equal to 3 3 3 1 plus 1 equal to 4, then y equal to 3 2 plus 1 equal to 7. You can see that it's a relationship between the x and y. It is a 3x plus 1. So what I'm doing here is I'm going to predict when I give the value. Already I given that data. I said, hey, this is my x value and this is my y value. So when I give a prediction, when I give a value the next time after I return the code, you need to predict the value for the x as a output y. We will create the code model sequential, and then also, so what it does, this code actually, this is a sequential. As I said, it's a stack of layers, one input tensor and the one output tensor. So when I say the dense is actually a closely connected layers. In this case, I'm not giving a multiple layer. I'm saying that I'm going to have a simple neuron for this project. I give us a 1, and then the input underscore shape is actually I'm giving only one feature as a one column. I can say that is a 1. So it's nothing but I'm giving the x value. This is a 1.0, 2.0, 3.0, and I'm giving the value because I'm not giving the multiple features. So it's a simple project, so I give it only 1. That's what the input shape is shows as a 1 in this case. The next line of code is actually we are going to compile. Let me run this. In this line of code, what it does is the first time when you compile, the code it checks, okay, for example, I have a 10x plus. First time it will check for the system is 10x plus 1. When the value is 1, it will see that, okay, the output is 11. The optimizer, what it does is the optimizer comes in the picture, and then it says, okay, let me do the what is the value and what is the previous guess. If the previous guess is 10, okay, it is a very far. What is a loss function? So it is a 6. So we have a difference of 6. Then it generate the next guess, and then it will go to this and then it do the next guess, and then say I got a now 6. Then it will do the another guess, then it will come to the 5, then it will do the next guess, then it will reach it to a 4. This the optimizer is actually it's trying to get the previous case and the input value. That is what the loss function is a mean squared error. Then it reduces to achieve the result. Well, I'll give an example. So you are going to participate in the long jump in the competition. The long jump competition is a 5 meters you need to jump. So first time you are jumping, and then you jump to a 4.5 meters. Then you can see the loss function is actually a 0.5 meters. Then you go back to the optimizer, and then they say, hey, you need to push a little bit extra, and then so that you can achieve more, and then you need to run also. Then you are trying the second time, you reach the 4.6 meters. Now the loss function is 0.4 because we minimize. Again you go to optimizer. The optimizer tells it, okay, you need to push it a little bit extra. Then you go to the 4.7, 4.8, 4.9. Then you will reach that. That's what the optimizer does in this book. So let's write it. We need to fit the model. We can say x, y, deploy. So we need to. So what we are doing here is I'm just giving a x as an input, and then I'm saying that the y is the output, and then I'm going to run for 500 times. So what it does is it's actually trying to predict, okay, what is the relationship between x and y. So that's what the model dot fit does. If you run the program, you can see the loss function actually. It says in the 12th run itself that it's minimize the loss from 0013, and then let's wait until it completes. Now you can see that the loss function is actually 5.4 is 10 to the power of negative 0.5. This pretty much is good. Let's do the model fit and we'll see. We compiled and fit the model right now, so let's go and do the prediction. So let's say simple math equal to model dot predict. I'm going to predict for number 4, and then we'll see what is the output, and then I'll print this value simple underscore math, and then I'll say simple. So let's run it and see what is the output. 12.99. okay, then it's good. It's actually, we have 4 value and the output is 13. It's predicted correctly, the good. So let's go for number 10. I would expect number 31. Yes, exactly, that's a good. Let's go for one more. 12 threes or 36, 37, exactly. So the output is correct. This is a simple neural network. We need to watch out few things here. One is you may not get the same output what I'm getting, and also you may get the loss function wider. When you get that, you need to rerun the code multiple times to get the output. So you can see that this simple math prediction is working very good. It's very simple one. And then we have written only a few lines of code, and then we have done our first neural network project. If you like this video, please subscribe to my YouTube channel and support me for posting the future videos as well. Thank you.